Okay, here we are in the next segment, particle motion. Um, know that as you're watching this, that I am going to be on office hours at 1:30 today to explain any of the problems in the packet. I'll go through any one of them for you. I'm going to do one today in the notes, but if you have questions, I'd be happy to explain more of them in depth. Um, so at 1:30 today, check that link out. Really important as you're moving, into this, getting ready for the AP exam, to have these notes somewhere. If you have access to a printer, the first couple pages of notes, really, really good to have. If you don't have access to a printer, then write them out. There's nothing. It's really important to have access to them and to know what they are. So, particle in motion. So, the kind of question that will come up with this is the tag will be something like the stem of the problem will be something like this. A particle moves along a straight line for 0 to 5. The velocity of the particle is given by that equation, and the position of the particle is given by s of t. It is known that s of 0 is equal to 10. And then they'll ask you questions about it. So really, any time it talks about a particle moving along a straight line, um, think of a road, think of a path, think of a horizontal line, going a particle going back and forth along that line, not going up or down and doing things like that. I'm not sure how it will be asked on the AP exam because many of these turn out to be calculator-based questions. I think they could still ask the question and give you a um, a picture of it and and kind of and kind of go back to what the picture might look like. There's an example that will be in the packet about Larry and Karen riding a bike to and from school, and that kind of thing will be asked, sort of a particle in motion with a graph. So I'll put that one in there. I don't think if you're looking prior to me putting these notes on, you might not have found it, but it will be up there as soon as I get off of this. So a couple things that you want to make sure that you know is some of these notes about what is this idea about speed, and what does that look like? What does it mean when we start talking about speed? So speed is really the absolute value of velocity. Um, speed is a non-directional way of talking about velocity. So it's speed is finding velocity and ignoring the negative sign. So then, once you find velocity, then ignore the negative sign. Because one of the things I like to think about is I like to think that velocity is really speed with direction. Meaning the negative or positive on velocity really kind of symbolizes what direction the particle is going. So if you're determining if the speed is increasing or decreasing, we talked about this in class a little bit, but really important, in order to determine if a particle is increasing or decreasing in speed, what you need to figure out is you need to look at if speed is increasing, that's when v of t and A of t have the same sign. So they're both negative or they're both positive. That's how you determine if speed is increasing. You need velocity and acceleration to be working together when you're asked if speed is increasing um, or decreasing. So then decreasing speed is when v of t and a of t have different signs. So the kind of thing where if velocity is positive and acceleration is negative, those two forces are working against each other. Speed would be then decreasing. So when you think about, like, this would be an example, is if v of 2 is greater than 0 and a of 2 is greater than 0, then speed is increasing in that. If v of 2 is less than 0 and a of 2 is greater than 0, then speed is decreasing. So you kind of want to check what's the sign on both of those things. Along those lines, just know that when v of t is negative, a particle is moving to the left. If v of t is positive, a particle is moving to the right. And I suppose you could kind of say, well, couldn't it also be moving up, or sorry, down here? And I say, yeah, I mean, if it's an up-down movement, and this would be up. So keep that in mind when you're talking about which direction a particle is going. Determining the sign on acceleration when given velocity. This is just a variation of the chart. You know, when we think about the chart, we could label it as position, velocity, and then acceleration. And if we make a table just the way we normally do, we can kind of get the same information on some level. There may be a little bit of kind of, well, what would that even mean? But if you think about it, when we think about this kind of thing, if this is increasing, so it's going up, or if the position is increasing, then velocity would have to be positive. Now, it doesn't really make sense to call it increasing in this case. You know, really what we'd maybe want to think about is this is moving right or up. So then if it's moving left or down, then velocity would be negative. It's kind of what we just covered. Now, it doesn't make a lot of sense to be talking about the concavity of position necessarily, but if velocity is increasing, acceleration then has to be positive. If velocity is decreasing, acceleration has to be negative. So when you think about like what's happening, you could still maybe kind of think about it being, you know, concave up, or concave down. But we won't really talk about it in those words. Really, what we'll kind of be focusing on is a left or right movement and a positive velocity, or right or up movement with a positive velocity, a left or down movement with negative velocity, and then if velocity is increasing, acceleration would then have to be positive. If velocity is decreasing, acceleration would have to be negative. So the chart kind of falls in line where if you're given something about velocity and you're asked if what's happening with acceleration, you can make the justification based on if velocity is increasing or decreasing. Okay, so moving on. Finding the distance when given velocity. If you're given velocity, the total distance traveled from A to B is found by doing the integral from A to B of the absolute value of velocity. That idea is if we want to figure out our total distance, we need to take the absolute value of velocity and integrate it, because we want to make sure that we don't have any negatives, because you can't have negative distance. But displacement is different. So the next thing, displacement, this is really the change in position. Right now, you are all displaced from school because you are not allowed to go there. So on a normal basis, you'd be in class and you'd be in school, but now you're displaced from there. And depending on how far you live away from the school, you're displaced a further distance. You know, Liz is probably displaced almost to North Dakota. So because of where she lives. So depending on where we live, we are displaced at a different place, a different distance. So when we think about displacement, displacement from A to B is the integral from A to B. And now velocity, the sign on velocity does matter. That will matter. So we don't want the absolute value on there. That way we can, it's kind of like yesterday I went to Costco, and so I left my house, drove to Costco, got all the stuff I needed, drove back. My displacement after the whole trip was 0 because I left home, came back to home. So I wasn't displaced at all. A change in position was nothing. But I certainly did travel a distance. So you got to think about it that way. Finding an amount when giving a rate in an initial condition, I'm not sure this is going to be tested on the exam. However, I think it's really valuable to know because it will help bring some context and understand things. So the new amount is equal to the old amount plus the integral from the old x value to the new x value. In this case, this will be t values of the rate dt. We've covered that a number of times. We've written it out a number of times. I think it's still a good thing to have. I'm not sure it will be actually tested. However, I think the second half will be tested, looking at this, this portion of it right here in the context of these problems really represents displacement, because usually that rate that's given is the velocity. So that really represents the displacement when we're talking about in the context of a particle in motion. A new position is equal to the old position plus the integral from the old value to the new value of the velocity. So that's just a variation of that thing. Okay, determining when a particle changes direction and when it's going. Really see the chart. Generally speaking, if v of t is negative, the particle is moving left or down. If v of t is positive, the particle is moving right or up. So when v of t changes signs, then particle change direction. So if v of t is equal to 0, the particle is stopped. Okay. Now the steps. We haven't talked about the steps diagram. I think it's probably going to be a pretty valuable thing to understand. Certainly going to come into play when you're asked anything about units. Remember that when we did this, I'm going to make this a pretty big diagram right here. So remember, this is down here is the position. It might be the amount. This is the velocity or the rate of the amount. This is the acceleration or the rate of the rate of the amount. Remember, to move up the steps, I talk about that being differentiation. Moving down the steps, I talk about that being integration. So some of the things that you can think about, if the position is in miles, the velocity might be in miles per hour. The acceleration then would be in miles per hour per hour. If you think about maybe this is in gallons, this might be in gallons per day, some kind of time limit. This would be in gallons per day per day. So important to kind of think about, where we are, what you're given. Normally, usually, you're given that middle step and you're asked to do something with that step. You're asked to differentiate to go up that step. If you're talking about acceleration, you're asked to integrate to go down the step to get some kind of a position or change in position even on these problems. Okay, so steps, pretty important piece of information there. Now, let's take this example. And I know this is a calculator question, right? I mean, so it's question number 2. So it's normally a calculator active question. Probably wouldn't be asked this way on the AP exam this year because you would be expected to use a calculator. In fact, you'll hear me kind of using a calculator on this question to get you'd be asked several questions on this to, with a calculator, but we're gonna do it anyway. We're gonna kind of set it up and talk about what it would look like and conceptually. So find all the values of t over which the speed of the particle is 2. So what we would really want to do on this is we'd want to know when is v of t equal to 2, or when is v of t equal to negative 2. That's really kind of what we would want to do. On this one, we might graph it. And I know you don't have a calculator. Calculator isn't going to help you on this one necessarily. On the actual AP exam that you're going to take this year. But if we were to do that, that's what we'd want to do. We might, determine this from the graph, or we might determine this from solving negative 2 plus t squared plus 3t to the 6/5 minus t cubed is equal to 2. Or we're going to do negative 2 plus t squared plus 3t to the 6/5 minus t cubed is equal to negative 2. That would be a solving it algebraically. I think this year the question would be, the exam would be a little bit easier. The equations would be a little bit easier because I would want to graph this. I would want to appeal to some kind of graph or to solve it algebraically. I'm going to stop there because this is, conceptually that's what we would need to do. But, on this particular question, you'd need to have probably access to a graphing calculator. But you don't have that right now. So it'll be asked a different way on the AP exam. Tune in at office hours and I'll kind of go over one of those where it'll be asked differently. Write an integral expression that gives a position of the velocity of the particle. So remember, this is, if you're going to find a new position, you're going to take an old position, which they gave you, plus the integral from the old position to the new position of negative v of t, right? I'm just going to write it as v of t. So, if I wanted to find this, essentially I have that the new position is equal to 10 plus the integral from 0 to t of v of t dt, and that would get me a new position. That could be completely asked on the AP exam and in that context, and so make sure that you know how to do it. If I wanted to find, use this expression to find the position of the particle at t equals 5, if I wanted to find s of 5, I would end up using a calculator on this one. But I think this equation is a really important piece to know because it kind of speaks to a lot of different levels. You're taking an old position plus the integral from 0 to t of the rate. Okay. Finding all the times when the particle changes direction. Particle is going to change direction. We're going to look at when does v of t change signs. We would probably do that on a graph. We'd want to look at a graph and see when does this thing change signs. Our justification would be something like changes direction because v of t changes signs, or v of t goes from positive to negative, or negative to positive, depending on the context. But that's what we'd want to look at. So that's where you'd want to look at. But you need to graph it, right? I mean, you need to have some sort of a graph. Again, we talked about without a graphing calculator, pretty difficult thing to do. If you're trying to, but you wouldn't be asked to do it on the AP exam this year. If you're trying to figure out, is the speed of the particle increasing or decreasing at t equals 4? Here's the thing that you would want to do. You would need to check, is v of 4, what is the sign? And, whoops, I should have written a 4 here. And a of 4, what is the sign? Really, what is the value? And then what is the sign? So really what I'm going to write down here is I want to know the value of this one. And I would want to know the value of this one. So if the same sign, then speed is increasing. If different signs, then speed is decreasing. So you got to check both. What's the sign on both velocity and acceleration? There's some problems that you have down here. I'm going to add one more at the end. I can't remember what year it was. It might have been 2012, but it'll deal with a more of a graphical approach to this, and hopefully that'll help you out. But I'll put that one on there. So come back at 1:30 and get on there with me, and we can go over more of these if this doesn't make any sense, if you're confused about it. Probably going to be something they ask. They ask it, about 80% of the time on these exams. They ask it. This year's a little different, but they do ask that question about 80% of the time. So if you need help, please come back and during office hours, and I'd be glad to help you. Take care. I miss you guys.